All right, welcome to the second part of the notes. What do we do when we've got fractions that don't seem to have any discernible factoring in them? What I mean by that is 2x squared minus 3x plus 7, if you really analyze that, it is not factorable. At the bottom, you can take out an x, but it doesn't cancel with anything on top. And you've got a limit approaching infinity. Okay. Now, here's the part that we have to think graphically about. So think about this as a graph. When we go to infinity, usually we think of horizontal asymptotes as infinite behavior. It's going to level off somewhere. It's going to be oscillation all over the place, like squigglies. Or it's just going to straight up go to infinity or go to negative infinity. Now, generally with these, when there's no discernible factors to cancel out on the top and bottom, you can be assured that there's going to be an asymptote of some kind. In this case, there's a horizontal asymptote. So there's a couple different ways of proving this. One way is by dividing the top and bottom by the biggest power on the bottom of the fraction. I know, it's kind of random. But think about it like this. If I plugged into my calculator like a billion into all these parts, and then I plugged in 100 billion, and then I plugged in a trillion, you'll see that the value of that number ends up being this, like getting closer and closer to it's never crossing this level. Okay? So if we divided the top and bottom by that x squared here, so it's like saying, it's kind of like if somebody say, hey, what's 6 over 12? And you're like, divide the top by 6, divide the bottom by 6. You're dividing by the biggest factor of 6 and 12 on the bottom. It's a half. I'm just doing the same thing with variables in this case. I'm saying, all right, I've got 2x squared minus 3x plus 7 on top. Let's divide everybody on top by x squared. And we got to do it on the bottom. I mean, it's the same number on top and bottom that we divide by. And what that does is it creates constants on the top and the bottom with variables. So this is 2 minus 3 over x plus 7 over x squared. This is 4 over x minus 5. Now, when the limit as x approaches infinity occurs with something like this, I mean, what happens if you take 3 divided by a billion? It's like, if I had $3 and divided amongst a billion people, how much does each person get? Not very much. In fact, the value keeps approaching 0 the more people you add. So, when you actually approximate the limit here, this part zeroes out. The infinity on the bottom basically dries all the value of the top up. Just like this, I mean, it's infinity squared, so it's drying up that more quickly. And then this also makes it 0. Limit as x approaches infinity of constant values remains the same. So you're left with 2 over negative 5. But here's the thing. Back in that last chapter, we talked about graphing with horizontal asymptotes. That was the shortcut. What's the leading power on the bottom and the leading power on top? That was your answer all along. So what I'm saying here is understand this process of what I did to get that asymptote, but recognize there's a shortcut. Okay? All right. Now, what if you compared that to negative infinity versus just positive infinity? Well, horizontal asymptotes really shouldn't change all that much. I mean, the moves that we did, because it's the exact same function here and here, the moves here would be the same. It's just, the question is 3 divided by negative infinity also approaching 0? And again, ask yourself the question, if I had $3 of debt divided by 1 billion people in the world, how much does each person owe? And it's like, oh, we don't owe much at all. If you just keep increasing that bottom number, then whatever's on top, either negative or positive, it's going to zero out no matter what. So the answer to 5b is also negative 2/5. Now that shortcut I just told you guys about only works if the top leading power matches the bottom leading power. It only worked here because x squared on top and bottom were the biggest leading powers. If they're different, you can't use that shortcut. So in number 6, they're different. So you can't use that shortcut. But you can use the process of dividing by the biggest power on the bottom. So you ask yourself, what's the biggest power on the bottom? It's x squared. Divide that by x squared, divide that by x squared. But you do it on top as well. Okay, so I can't just say like, divide the bottom by x squared, divide the top by x to the 4th. It's the same value. Otherwise, you start to disobey the rules of math. So what does that do? It cancels out and creates a constant here. On top, you've got 2 over x squared minus 8 x to the 4th over x squared. That's x squared. And then you got 2 over x minus 3. Now think about when you apply infinity to any finite amount. This is going to be unscathed. The negative 3 isn't going to be affected. However, 2 divided by infinity zeroes out. 2 divided by infinity squares zeroes out that much quicker. Now here's different. Here I've got negative 8 times, and just to humor you guys, I'm going to plug the infinity in. You can't really plug it in, but we can like visualize what would happen if we plugged an enormous amount into a square, right? And then negative 3 still on the bottom. 0 minus 3 is negative 3. It's basically like saying, okay, infinity squared shares kind of the behavior of infinity, right? It's just like, it's still a positive number that is gigantically huge. And a negative 8 divided by a negative 3 makes it positive 8/3. I'm going to put this in quotes. 8/3 times infinity. Well, that's like taking a giant amount and multiplying it by 2 2/3. It's an even bigger amount. So what you do is you say, that limit actually equals infinity. And I'm going to specify positive infinity because think about if this were plus 3x squared on the bottom. If that were plus 3x squared on the bottom, then that's a plus 3 on the bottom. This answer would be negative infinity. So you just got to keep an eye out for that kind of thing. Hopefully that makes sense. All right, with number 7, what happens if there's just a polynomial in front of you? Okay? So this can get kind of weird. I got 2, and if I did the infinity plugin like normal, it would create something very weird. It'd be like saying, all right, take infinity to the 4th power. Even powers retain positive value. So it's like, oh, what's -8 times a positive giant number? It's now a negative giant number. And what happens when you take 2 minus that? Well, it just kind of gets absorbed in the whole mix of things. So it's sort of like this is negative infinity, and this is positive infinity. I'm sorry, it's too bright. Negative infinity. With the 2 minus it as well, right? Plus infinity. Minus infinity? See, this is where a lot of students get kind of in trouble because they're like, well, infinity, negative infinity plus infinity is 0, which is like, hold on. This infinity is getting wildly bigger than that infinity. By that I mean, just think about it. If you take 1 billion to the 4th power times -8, then you take 2 times 1 billion. Now the 2 times 1 billion, 2 billion, when that number inside the billion gets bigger, it's approaching infinity. Yeah, sure. But this one that's taken to the 4th power is getting there infinitely quicker. So this is the dominant infinite value. And that's what happens in polynomials. When you are talking about the limit as x approaches infinity, this is really the only one that matters, the leading power. The business of the leading power affects everybody else. So our answers actually, this and this and this are kind of, they're almost like we're not regarding them very much. We're not saying like, hey, you guys count. That's the only one that really counts. So when you plug in infinity here, you get negative infinity. And that's the answer. It's not that these 2 infinities cancel each other out and you're left with negative infinity at the end. Okay. So, you know what? One more example. I was thinking, what if we had the same situation, but we were approaching negative infinity? Well, if it's a polynomial like we have here, you're saying to yourself, I don't care what anybody else is. It's just the leading power. The leading power tells me everything I need to know. So -8 times, and again, I'm being very liberal in my approach to this by saying, plug in negative infinity. You can't really plug in infinity. But you can say that this negative on the infinity, when taken to the 4th power, basically gets turned into a positive infinity. But that negative on the outside is going to make it negative infinity again. All right, I've never said infinity that many times in a row. Wow. All right, I'm kind of going hoarse. I think that's it. So the assignment on Google Classroom, I'm not going to make it due till Monday. I'm going to give you a lot of time to figure this out. There are 21 exercises. Some of them are super simple, though. Remember, if there's no domain issue with the limit, you should be able to plug it straight in. All right. Hope these videos are helpful, and hopefully you guys are making good progress and having fun with this stuff. Yeah. See ya.